Hey kids, Flexing Teacher Weber here. So we've been looking at the Pythagorean theorem. You did some investigation into right triangles where you actually, most of you discovered the idea of the Pythagorean theorem, where you have a right triangle and the squares of the legs are the same as the square and the hypotenuse, or the sum of the square of the legs is equal to the square and the hypotenuse. Yesterday, hopefully you watched some of the videos on the Pythagorean theorem on Pythagoras. And today we're going to start using the Pythagorean theorem. It's essentially another math equation. Now, what we have here is a right triangle. The lengths of its legs are 12 centimeters and 5 centimeters. Now, how do I know those are the legs? Because the legs are always beside the right angle. This is the right angle right here. So that means the hypotenuse is side C. So the way you do this is you use the math equation a squared plus b squared equals c squared, or a times itself, a squared, and b times itself, b squared and c times itself, c squared, a squared plus b squared equals c squared. So you use that equation, and the actual variables don't matter, as you'll see later on, but often it's just known as a squared plus b squared equals c squared. I'm also going to write it like this: c squared equals a squared plus b squared, because we know that math equations can be flipped like that, right? Now all we do is we do all the stuff we learned with math equations. This is why we do this now, because we've learned all about math equations, and this is just another math equation. So we're going to substitute in what we know. We don't know c squared. We know that a is 5, so 5 squared. And we know that b is 12, so 12 squared. Now if we use order of operations, we have to do our exponents, we have to do our squares. So c squared equals 25, 5 squared is 25, plus 144. And c squared equals, when I add those up, I get 169. But we don't want to know the value of c squared, we want to know the value of c. So the way we figure that out is to go from c squared to c, we have to take the square root of it. And I do the same thing on the other side, because if I do the square root of one side, I have to do the square root of the other side. And so now I get that c, oh, I don't want red, I want blue. We get that c is equal to 13. And that's 13 centimeters. And that's the length of side C. Now we call this, when we have a triangle, and it's always a right triangle, that has, so if we take side 5, and side 12, and side 13, those three triangle sides follow the Pythagorean theorem, so we call that a Pythagorean, I just got to watch how I spell these, Pythagorean triple. And if three sides of a triangle follow that, then we know it's a right triangle, because the Pythagorean theorem only applies for right triangles. That's how we use the Pythagorean theorem to solve math equations. Let's do a couple more. I'm going to flip forward. Doink. See, almost this time the triangle has different side names. It doesn't matter, right? The Pythagorean theorem says I take the square of the legs. So this leg is 9 and this leg is 12, or it's also known as x and y. And then the side opposite the right angle is the hypotenuse, z. So in this case we'd say x squared plus y squared equals z squared. I'm going to put a little line there so my z doesn't look like a 2. Or, if you want, you can say z squared equals x squared plus y squared. Same thing. Okay, so we don't know the value of z, so we'll say that that's z squared. And the value of x we know is 9, so 9 squared plus 12 squared. And z squared equals 81 plus 12 squared is 144. And as we keep solving that math equation, z squared equals 225. Now we don't want to know the value of z squared, we want to know the value of z. So take the square root of z squared, and if you do that to one side, you have to do the same thing to the other side. Take the square root. So z equals 15. In this case, it's meters. And so just to remind you of something else, that means if we take the sides 9, 12, and 15, since they follow the Pythagorean theorem, we call this a Pythagorean triple. One of my high school teachers pronounced it as the Pythagorean theorem. I don't know which one's right. I'm not really too concerned. But I've heard Pythagorean or Pythagorean. I'm sure Pythagoras just probably went by the name P. Diddy to his friends, so it doesn't really matter, right? Seemed like a pretty laid-back guy. Okay, so that's another example with the Pythagorean theorem. Let's do one more. Okay, another right triangle. This one doesn't have any variables. Okay, but what we need to look for are what are the legs and what's the hypotenuse. Okay, so this is the right angle, and the sides beside the right angle are the legs, which means that the side opposite the right angle is the hypotenuse. And this is the side we don't know, so I'm going to call that x. And the Pythagorean theorem says you take the square of the hypotenuse. Now the hypotenuse is x. You take the square of it, and that equals the sum of the squares of the legs. So we'll do 5 squared plus 7 squared. Or I could write it as 7 squared plus 5 squared. It doesn't matter. X squared equals 25 plus 49. Okay, keep working down the page. X squared equals 20 and 40 is 60, 5 and 9 is 14, so that makes 74. Now here we have an issue. This time we don't have a perfect square. Now we still need, once we get down to x squared, we still want to find the value of x, so I'm going to have to do the square root and the square root. Now this time, we don't know offhand, it's not a perfect square. So there's two ways we could do this. In our previous unit, we estimated these with number lines. Now I don't mind in this unit if you want to use your calculator, your square root button on your calculator to find the square root. So on my calculator, I would do 74 and I would do square root, and I get 8.602325. Now I didn't specify how many decimal places. Let's just go to one decimal place. And let's say x is equal to, and I guess I shouldn't say equal, because it's not exactly equal. X is approximately, so I'll use the approximate symbol, 8 6/10 meters. And I hope you're always realizing here that the hypotenuse is always the longest side of the triangle, right? So x is 8 6/10 meters, approximately. So those are 3 problems we have solved where we have found a missing hypotenuse on a right triangle. I'm going to do one more video where the problems change a bit and the triangle is going to be missing the lengths of one of its legs. So we'll do that in the next video. Hopefully this is sort of making sense. Flexing Teacher Weber, out.